a circle with radius of 1 centered at 0, 0. That's it. It's a center with a circle with a radius of 1. That's all there is. Okay? Do you remember the equation for a circle in a coordinate plane? Does this look familiar? X minus h quantity squared plus y minus k quantity squared is equal to r squared. Don't tell me that you remembered. I get we didn't remember it. Does it at least look familiar? Like, hey, I think I've seen that before. I hope you've seen that before. That was lesson 1.8 from first semester. If you tend to forget a lot of things, math is going to become more challenging as we move along. We do expect that you remember most things, especially as we bring them back for relevance. But the fact is that's the equation for a circle. So suppose there was a center of, say, 3, -4, and a radius of 7. Well, then the equation would be x minus 3 quantity squared plus y plus 4 quantity squared is equal to 49. So hopefully kind of remember doing something like that a little bit. Okay, we're good? So if the center is 0, 0, then we don't have to worry about h and k, and it's just x squared plus y squared is equal to r squared. Did that look familiar? That's the same thing as what? The Pythagorean theorem. In fact, all of trigonometry is based off of that one thing. Everything we do second semester is based off of this one thing. You're like, well, that'll be kind of boring. No, actually, trigonometry was fine with the world for thousands of years, and then finally came along with something called algebra. But in this situation, the radius is 1, and so we have x squared plus y squared is equal to 1. That is the unit circle. It's very simple. This is a picture of the unit circle. The radius is 1, and if we put it on the coordinate plane, it has some important points that we like to talk about. For example, this point right here is the location 1, 0. Who can tell me what this location would be? 0, 1. What can that location be? -1, 0. And at the bottom, we have 0, -1. Jaya, is this something that you produce from time to time in calculus? Yeah, this is something you always want to be able to produce. Do you see how I came up with that? This is something you'll continually refer back to, so make sure you can generate that. Going hockey? Later, Gator. Where are you headed? Oh, got it. It's Winona. Go turn those win hawks into lose hawks. All right. You have no chance. Wow, what? Technically, there's always a chance, right?
Very, very slimble. Like maybe like 0.5%.
Maybe a 0.5%. 0.5%. Let's see. That's like, it's like 0.005. Wow, that's small. Okay. Well, good luck. Throw the first punch. Wait a minute. They shouldn't do that in high school hockey, should they? No. No. Okay, so the unit circle, that's the, this is the picture. There's other points that sit on the unit circle. It says confirm that this point is on the unit circle. So what I'm going to do is I'm going to take that x value and that y value and plug it in, and it should give me 1. So let's try that. The root of 3 over 2 squared and -1 over 2 squared. That should produce 1. What do you get if you square the root of 3 over 2? 3 over 4. Square the top, we get 3. Square the bottom, we get 4. What do you get if you square -1/2? 1/4. Is 3/4 plus 1/4 equal to 1? So we have confirmed that root of 3 over 2, negative 1/2 is a point on the unit circle. Okay, so that means if you were to go over the root of 3 over 2 and down 1/2 of a unit, you'd be somewhere right on that circle. Okay, good. Let's do the second part. It says point P lies in the third quadrant. So we have first quadrant, we have second quadrant, we have third quadrant, and we have fourth quadrant. Okay, those are our quadrants. So it says the x-coordinate of point P is negative 2/5. So that means I'm back 2/5 of a unit. Okay, so I go back 2/5 and I go down a certain amount. So point P is going to be somewhere around there. It has an x value of negative 2/5. It wants us to find y. It says find point P, so we need the y value. Anybody got an idea of how I can find the y value? Yes, Kenny? Yeah, if we plug the negative 2/5 in, very good. So x squared plus y squared is equal to 1. If we plug in the negative 2/5, we can solve for the y value. Important here that you see each piece. If I square negative 2/5, square the top, I get 4. Square the bottom, we get 25. And I'm going to rewrite 1 so that it has a denominator of 25. So I'm going to write it as 25 over 25. Subtract the 4 over 25, I get y squared is equal to 21 over 25. And then I square root both sides. And y is equal to, if I take the square root of a y squared, what do I have to do? List both the positive and the negative. The root of 21 on top and 5 on the bottom. So notice how I get two options. Do I choose the positive root of 21 over 5, the negative, or do I choose neither or both? What? Very good. So if you notice, if you were to go back negative 2 over 5, and if you were to go to up, it would bring you up here. That would be the positive one. So that'll be in quadrant 2. But we want the quadrant 3 one, so we're going to choose the negative one. So we have negative 2/5 and negative root of 21 over 5. So that's point P. Okay. All right. The last thing that we will have time for today, flip it over to this side. You will not have an assignment today. Your assignment will come tomorrow. Degrees and radians. Degrees and radians. Good times, good times, good times. Caden, you get to go live in another country. Where would you like to live? Going to Canada. Okay. The Canucks, right? Hockey team. Good place. I hear there's some mountains up there. All right. So if you go to Canada, what's going to be different? The weather. It's going to be a little bit colder. What else? Laws. They might have different laws than we have, right? When you drive, things will be different as well, won't they? It's going to be different when you drive. Do you drive on the other side of the road in Canada? I think we drive on the same side. I think we share that in common. But I do think that instead of miles per hour, I think they do the kilometers per hour, don't they? Yeah, it's always that awkward thing when you watch a baseball game. It's like we have 328 feet down the left field line. They have 100 meters. Like, honestly, who would ever do 100 meters, right? If you think about it, the rest of the world has all adopted that whole metric system piece, and we're the only ones that don't, right? Yeah, go Haiti and Liberia, right? We're like, yay, let's hold on to that, right? And it's like, why don't we? But we love our feet and our inches and our miles and all that stuff, right? But just think about it. Think about the flip side. Like you go over to England, you're talking money. You like go to buy a Mountain Dew, and somebody's like asking, like, well, do you have a ruble and a shekel and like a, you're like, what are you a pound? What's a pound? It's like if I buy ground beef for crying out loud. You know what I mean? It makes no sense. Just think of how confused people are. They come here, they're like, yeah, so yeah, it's like I'm 6 feet tall. 6 feet, like you put your foot, like what? Doesn't make sense, does it? Same way in mathematics, folks. When we measure angles and we use a variable for angle measure, we don't use x, we don't use y, we use theta. Theta equals an angle measure. Theta is like a circle with a line through it. It's like an egg with a crack. Okay? It's spelled theta. That's the Greek. The English is, let's see here, T-H-E-T-A. Theta. Theta, theta, theta. You're going to use that variable more times than any other variable this semester. Okay? So theta refers to an angle measure. Kind of like how we use miles, sometimes we use degrees. But how we most often use, say, meters or kilometers, we like to use what we call radians. There's different ways to measure angles. Okay? Now, how many degrees are there in a circle? 360. So we're going to put 360 degrees right over here. That will make this 90 up here, make this 180 over here. We have 270 down here. Do you ever wonder, is 360? Like, why 360? Like, why don't I just go like an even 400? Or maybe 100 or something like that. They went to 360? It's about revolution, right? And what's similar to 360? 365 days in a year, right? You see, when trigonometry was being developed, you guys, that was in 750 BC. That was over 1,200 years before algebra was developed. You know what kind of problems they were trying to solve back then? They're trying to figure out the orbit of the planets. So we have a base number of 10 in our number system. The Babylonians, they didn't start with a base number of 10. Their base number was 60. They chose 360. You can see why if their base number was 60. So that's what they chose. That's why we got 360. I told my daughter, she says, what's a degree, Dad? And I say, a degree is 1/360th of the circle, right? I mean, if you're wondering what 1 degree is, it's just like a small sliver, right? My daughter asks for pizza. I'm like, great, I get 90 degrees, you get 1 degree. She's not very happy, right? It's like, what's going on? But if I say you get 1 radian, is she happy or is she sad? Well, who knows? What is a radian? And here's what a radian is. The word radian comes from the word radius. It's when the radius is equal to the arc. So I'm going to draw an arc, and whenever the length of the arc is the same as the radius, that's when I'll have 1 radian. So you tell me, is this blue arc more than 1 radius or less than 1 radius? It's more than that. All right, how about this blue arc? Is this blue arc more than 1 radian or less than 1 radian? That's less than. Who's a brave soul here? Bravery. Kenny. Kenny, you tell me when my arc is the same length as the radius, approximately. Tell me when to stop. Have a conversation with the person next to you. Is that blue arc longer, shorter, or the same as the red one? Talk. Go.
I don't think I got it.
All right, what do you guys think? What do you think? Everybody agree it's longer? Okay, all right. So good job, Kenny. Thank you for being brave. Nobody else was brave. We'll let somebody else who thinks they... Well, Kenny, we'll give you a second shot. You tell me when you think I'm closer now. Have a conversation. Longer, shorter, same. Talk.
Little short. Close. You were closer. I think you were shorter. Yeah, I think you were closer, but just a bit short. Yeah, that's what I'm saying.
I'd say it's pretty good. That's about 1 radian. So if I tell my daughter to get 1 radian of pizza, she's like, hey, good deal. I'll take it. That's a decent slice right there, right? Please don't go on the bell goes. I'm just going to go a hair over. Question is, what does 2 radians look like? That would be about 2. And right now you're saying to yourself, well, I suppose that there's exactly 3 that fit. Not quite. Just a little bit more than 3 fit in 180 degrees. Oh, you guys got to see it before you leave. What's a number that's just a little bit more than 3? 3.14. There's exactly pi of them that fit in 180 degrees. We'll pick up there tomorrow. Have a good day.
That's